and we look at a comparison that involves population sizes f and L, then this sum has to be greater than or equal to the threshold that applies if you have n and L as the population sizes involved. This is a function with these properties, or is sometimes referred to as a metric preserving function. It's not quite the same because we have the absolute value relationship that has to be met. But essentially what this says is we have to make sure we don't mess up transitivity. So this has to be true for all possible population sizes. And L. And for a while we thought that might be enough, but it isn't, because there can be trouble occurring in knife edge and borderline cases, where you can end up with violations of transitivity, and we need to avoid that. To do that, we need another property, and that's here is what it requires. Consider three distinct or pairwise distinct population sizes. They're all, of course, positive integers. If it is the case that the inequality, the threshold inequality we apply for comparisons involving a difference between n and m people, and the threshold inequality that we apply for comparing distributions with m and l people. These are both weak inequalities. Then, in order to make sure we don't violate transitivity in the knife edge case, we have to make sure that one of two.
Oh, can I ask a question? So basically, if the h function is always 0, this ordering is just a critical utilitarian.
Yes.
And so the h function is kind of inertia.
This is a threshold that you want to say. If you may be not comfortable with making a judgment, particularly if population sizes are very different, and that allows you these differences to pass more than 0.
So it allows more general,
like
of course, critical. Okay.
Yeah. Yeah, if h is 0 everywhere and the inequality is weak everywhere, you just get standard critical level utilitarianism. Okay, so if we have a situation where we link together two weak inequalities, then in order not to mess up transitivity, one of two consequences have to apply. The first possibility is either that the inequality that we apply to comparisons involving n and l individuals also is a weak inequality, or, as a second option, the triangle inequality that I introduced earlier is actually satisfied with a strict inequality. And it turns out these restrictions on the possible combinations of threshold inequalities and the threshold function are needed to preserve transitivity, and they're also sufficient. It took us a while to figure that one out, but now we are at a stage where things are reasonably settled. Oh, by the way, while I'm speaking about things that are settled or not so settled, apologies for not submitting a paper. The reason is this is still very much work in progress. And later on I may be able to say something about the discovery that we made very recently. All right, so this is basically our general class. It's based on critical level utilitarianism, but we introduce thresholds to allow for non-comparabilities. Now, there are two special cases that may be of interest here. So one special case is what we call proportional threshold critical level utilitarianism. CLU. And in that case, we have a situation in which the threshold function h is a linear function. H of k is equal to beta times k for all k in n. Don't have to worry about the zero because we assume that it's if there are if the two populations of two distributions to be compared are the same, we just apply the critical utilitarian ordering where beta is a positive constant, and another option is constant threshold. So constant threshold critical utilitarianism assumes that the threshold is a constant delta for all possible differences in population size. What is particularly interesting, we think, is if you look at these proportional principles, these proportional quasi-orderings, the critical band utilitarian class is contained in those. And here is why. Well, I'm not going to go through a proof of that. It's basically just algebra. So, for those of you familiar with the literature, critical band utilitarianism says, well, if we want to decide whether one distribution is superior to another, we have to make sure that this judgment